All right, this is part 1 of the chapter 8 test review. For number 1, we're trying to complete the square. I would add 10 on both sides of the equation to get v squared minus 10v is equal to 7. At this point, I'm going to be dividing negative 10 by 2 and then squaring it and then adding that to both sides of the equation. So the b, or the coefficient of the linear term in this case, is going to be negative 10. Negative 10 divided by 2 is equal to negative 5. I'm squaring negative 5 to get 25. So v squared minus 10v plus 25 is equal to 7 plus 25. The reason why I'm adding 25 is I want to write this in the form v minus 5 squared equals 32. At this point, I'm going to take the square root of both sides of the equation. The square root of v minus 5 squared is v minus 5. The square root of 32 is going to be plus or minus. I can simplify 32 as 16 times 2, or 4 square root 2. So I'm going to add 5 on both sides of the equation, where my final answer is 5 plus or minus 4 square root 2. And again, this is technically two answers, 5 plus 4 square root 2, and 5 minus 4 square root 2. All right, that was number 1. For number 2, I'm adding 13 to both sides of the equation. B squared minus 14b is equal to 22. I'm going to take the negative 14 and divide by 2 to get negative 7. Negative 7 squared is 49. So b squared minus 14b plus 49 is equal to 22 plus 49. On this side of the equation, I'm going to write this as b minus 7 squared. So a good way to remember is that b divided by 2, what number that we're going to be squaring is going to be what's inside the parentheses as that binomial squared. This is equal to 71. I'm going to take the square root of both sides of the equation to get b minus 7 is equal to plus or minus the square root of 71. And I'm going to add 7 on both sides to get b equal to 7 plus or minus the square root of 71. I'm going to look back at that answer to make sure that I'm not supposed to simplify. Yep. Okay, so this would be my final answer. Again, this is technically two solutions, 7 minus the square root of 71 and 7 plus the square root of 71. For number 3, they're asking us to find the discriminant. So the discriminant is b squared minus 4ac. It's what's inside the square root in the quadratic formula, which I'm going to give you guys. We won't have to memorize the quadratic formula. But to be able to find this, we need to set our quadratic equation ax squared plus bx plus c equal to 0. So this looks like I need to add 4 on both sides of the equation. Which when I do, I get 6p squared minus 4p equals 0. So now a is 6, b is negative 4, and c is 0. So b squared is going to be negative 4 squared. Sorry, my dogs. So it's negative 4 squared minus 4 times 6 times 0. Which this is going to be 16 minus 0, because 4 times 6 is 24, but 24 times 0 is 0. So now my discriminant is positive. When we talked about this, it was, in this example, it's greater than 0. This is going to be 2 real solutions. In number 4, I'm going to subtract 3 on both sides of the equation. 8n squared plus 5n plus 2 equals 0. Again, referencing this is ax squared plus bx plus c. A is equal to 8, b is equal to 5, c is equal to 2. 5 squared, 5 squared minus 4 times 8 times 2. So this is going to be 25 minus 4 times 8 is 32. 32 times 2 is 64. If it was 25, if it was 20 minus 60, or if it was 25 minus 65, this would be negative 40. But it's 25 minus 64. So this is going to be negative 41. So because I get, and even if we got this part here, when we get the negative sign, this is going to be no real solutions. Technically, there's 2 imaginary numbers, 2 complex solutions, but there's going to be no real solutions. I feel like I'm goofing on this part. 64 minus 25. This would be 9, it'd be 39. Yeah, I guess it'd be negative 39. All right, so on this next one here, when I have to add 5 on both sides of the equation, negative x squared minus 4x minus 4 equals 0. A equals negative 1, b equals negative 4, c equals negative 4. This is going to look like negative 4 squared minus 4 times a negative 1 times a negative 4. This is 16 minus 4 times negative 1 is negative 4, and then times negative 4 is a positive 16, so it's 16 minus 16. This is 0. There's one real solution. All right, then this next part, these next 2 are asking us to solve the equation with the quadratic formula. Again, I'm going to give you guys the quadratic formula, so it's not something you have to memorize, but just like the work we did with the discriminant, I need to be able to set the equations equal to 0. So I'd add 11 on both sides of the equation. 10a squared minus 4a plus 11 equals 0. A equals 10, b equals negative 4, c equals 11. And the formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So it's a negative of a negative 4 plus or minus the square root of negative 4 squared minus 4 times 10 times 11. And then this is going to be divided by 2 times 10. So I got 4 plus or minus the square root of 16. 10 times 11 would be 110. So 110 times 4 is going to be 440. Minus 440. And then 2 times 10 is going to be 20. Just want to double check. I may have accidentally give us an example with I. No? Which one? Oh, yeah. Sorry, this one should not have had the I in it. I must have missed this part here. So, this is going to be 4 plus or minus the square root of, hey, Baxter, no. So we're going to pretend for a second that this is 440 minus 16, so I didn't want to have an example that had a negative radical. If you were to actually do 16 minus the 440, you get negative 424, which is divisible by, which is divisible by 4. So it's still 4 plus or minus. I know this is negative, but we'll pretend it's positive for a second because you guys aren't going to have complex examples. 424 divided by 4 is going to be 106. Now the square root of 4 times the square root of 106 would look like 4 plus or minus 2 square root 106 over 20, or 2 plus or minus the square root of 106 divided by 10. The reason that that example had an I here is because the square root of a negative 1 is I. We could factor that out the same way we factored out the 4. But on your examples, you won't have any negative square roots. All right, for number 7, I'm going to subtract 14 on both sides of the equation. 10x squared plus 6x minus 14 equals 0. A equals 10, B equals 6, C equals negative 14. Sorry, my dog's driving me nuts. Baxter, back off. No. So this looks like negative 6 plus or minus the square root of 6 squared minus 4 times 10 times negative 14. All over 2 times 10. So this is negative 6 plus or minus the square root of 36. Now, this would be 40 times 14. Plus 560 over 20, or negative 6 plus or minus the square root of 596 over 20. I'm going to try to use some smaller numbers when you guys are actually taking the test, but in this example here, when I've got 596, if I divided that by 4, I'd get 149. Which again, if I can write it like 4 times the square root of 149. This would be 2, so it's negative 6 plus or minus 2 square root 149 over 20. Which I can simplify as negative 3 plus or minus the square root of 149 over 10. Alright, I'm going to pause this part of the video because this is the work we did in 8.1 and 8.2. The second video is going to have the work we've done on graphing. Again, you don't have to memorize the quadratic formula. Please bring a calculator for tomorrow, and if you have any questions, email me.